In this video, we're going to have a look at a few examples of using integration by parts. If you haven't watched the previous video where we proved the formula, it might be worthwhile to go back and watch that. But the formula is written here in blue anyway. So, in our first example, we're integrating x times e to the power x. Now, if you have a look at the formula, we have, on the left-hand side, we have an integral of a product, but the product is actually given by u times v dash. It's not given by u times v. So what we need to do is we need to be very careful in what we choose to be our u and what we choose to be our v dash. Because whatever we choose to be our u, we can see that in the answer, well, u is going to appear again, but we also need u dash. So that means we need to be able to easily differentiate u. Now, for most functions, that's not a problem. Differentiation isn't really an issue. But if you have a look at the other function, it's actually v dash, which means that when I do my integral, I'm going to end up with a v and a v, which means I actually have to integrate v dash. Now, that is an issue because, yes, we can differentiate most functions, but not all functions have a very easy derivative. So we need to be careful with what we choose as our u and our v dash. Now, there is a rule which helps you remember or decide on which function to choose as u. And I'm going to write it on the side here. It's LIATE, L-I-A-T-E. Now, this is a mnemonic. It stands for logarithm, inverse trig functions, algebraic, trigonometry, and exponentials. Okay, and this is to help you choose the u in uv dash. Okay, so we always want to choose log first, and then inverse trig, then algebra, then trig, and then lastly exponentials. So in our particular example, we can see that we have x, which is an algebraic function, and we have e to the x, which is an exponential function. And because a comes before e in this mnemonic, that means we're going to choose u to be the algebraic term, which is x. So let's start with that. U is going to be x, which means that u dash, well, that's going to be 1. Okay? Then we have v dash has to be e to the x, and v is going to be, well, the integral of e to the x is e to the x. And you can see why the exponential is the last one, is the last choice for you, because it's very easy to integrate exponential functions. Okay, so now let's go ahead and apply the actual formula. Well, the formula says that this integral should be u times v, so x e to the x, minus the integral of u dash times v. So minus the integral of 1 times e to the x dx. Of course, 1 times e to the x is just e to the x, and then integrating e to the x gives us e to the x. And then we just have plus c. And that's our final answer. The second example is the integral of x times log x. So here again we have a product of functions, which means that we're probably going to use integration by parts. All we have to decide is what do we choose as our u and what do we choose as our v dash. Again, if you have no idea what to use, you refer to LIATE. Okay, and in that case, that tells us that we're going to choose the logarithm function as our u. So u equals log x. To differentiate that, we would get 1 on x. We have to choose v dash as x, and integrating that would give us x squared on 2. Okay, now we apply our integration by parts formula. So it's going to be u times v, so log x times x squared on 2, which I might just write out the front, minus the integral of u dash v. So minus the integral of 1 on x times x squared on 2 dx. Okay, this is going to be x squared on 2 log x minus, here we're going to have the integral of x squared divided by x will give us x, and then we have just a 2 on the bottom. So this is going to be x on 2. If I just move this up a little bit, then our final integral is going to be x squared on 2 log x minus, integrating x on 2 will give us x squared on 4 plus c. Okay, and that is our final integral there. The last example is the integral of x cubed times sine of x squared. Now here we have a product of functions, so we're going to use integration by parts. And if we look at LIATE, that would tell us to choose u as x cubed. So u would be x cubed, and our v dash is going to be sine of x squared. However, sine of x squared is actually very difficult to integrate, if not impossible to integrate. So this is a situation where a blind use of LIATE is actually going to lead to some problems. What we could do though is we could recognize that if we had the derivative of the function inside sine, that is, if we had the derivative of x squared, which would be 2x, we might be able to integrate that. So if we have an x sitting out the front, remember we can always add or multiply and divide by constants, that's not an issue. But if we had an x sitting out the front, that would be a good thing. So what we should do is we should think of our integral in the following way. We should think of it as x squared times x sine of x squared. And now here we can clearly see that this would be our u and this would be our v dash, which is what we're going to use here. So I'll change this cubed to a squared. And from here we can do our derivatives and integrals for our formula. So u dash is going to be 2x. Now we need to integrate this to get v. So we kind of have to do an integral to do our original integral. So we need to integrate x sine of x squared dx. Okay, now if I multiply by a 2 and then by a half, that makes it so that I have the derivative of what's inside the sine here, which will actually make this minus a half cos of x squared. So what I did is actually just did a substitution in my head here, a mental substitution. Anyway, this is what our v is going to be. So now we can go ahead and apply the integration by parts formula. So the integration by parts formula is uv, so x squared times minus a half cos of x squared minus the integral of u dash times v. So 2x times negative a half cos of x squared dx. Okay, let's write this first bit a little bit more neater. So that's just going to be minus a half x squared cos of x squared. Now I've got a 2 and that cancels with that 2. And then I've got 2 negatives which make a positive. So I'm integrating x times cos of x squared dx. Now again, I'm going to make a mental substitution, but what I'm actually doing, I'm making the substitution, let's use the letter m. M equals x squared. Okay, and if you wanted to, actually, you know what, let's just do it, a proper substitution, just so we don't confuse anyone. dm on dx equals 2x, and so dm equals 2x dx. Well, actually, maybe let's cross out that 2 and write a half here. All right, so we're making that purple substitution in our last integral here. So we have minus a half x squared cos of x squared. When I make this substitution, it's going to be, well, x times dx, that's a half dm, so the half can go out the front and the dm here. And then I'm integrating cos of m. Okay, integral of cos of m isn't too difficult. We should know that that's going to be sine. So this is a half sine of m plus some constant. but we need to change it back to something in terms of x. So this is going to be minus a half x squared cos of x squared plus a half sine of x squared plus c. Okay, and that's our final answer. So in this example, I particularly chose it because it's an example where using LIATE blindly is actually going to lead to problems. We have to be a little bit careful about what we choose to be our u and our v dash.